This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 2 weeks. Thanks to our audience and the partners listed on our website for supporting the podcast. Hello everybody, welcome to SE Radio. In this episode, we have something about test-driven development, an interview by Johannes Link with Lasse Koskela. Johannes has considered joining the SE Radio team, and the episode you hear today is his prototype interview. However, he has decided to not join the SE Radio team because he noticed that it's more work than he has time for in his current situation. We still decided to publish his interview because we think it's good content and also, obviously, to be fair towards Lasse. The audio quality is not quite up to our usual standards, but I think that the content is certainly good enough to even publish it, although the quality of the recording isn't that great. And so if you don't like the audio quality, you don't have to post that to the forums. We know. Okay. So thanks again to Johannes for recording this interview, and also, of course, thanks to Lasse for participating and providing the backbone of the content. Okay, that's it. Have fun.
Welcome, listeners, to a new episode of Software Engineering Radio. My name is Johannes Link. I am an independent software coach living in Germany, and I'll be your host today. I'm very happy to have Lasse Koskela as my guest. Welcome, Lasse.
Well, thanks for having me.
This is my first show for SE Radio, so I'm feeling pretty nervous. What about you?
Well, it's my first time being an interviewee here as well, so we're both nervous, I guess.
The topic of this interview is test-driven development, also known as test-driven design, or test-first development, or test-first programming, or short TDD. Test-driven development was mentioned a few times in previous episodes, but has never been covered in any detail. Before we dive into the intricacies of TDD, I'd like you, Lasse, to tell us a bit about you as a person and your professional life.
Right. I'm a geek, geek to the bone. So I've been working in the industry for a paycheck for around a decade, and basically doing most of that doing programming. So that's my background. For the past 4 or 5 years, I've been almost exclusively working with agile methods. And doing a bit of coaching, both for teams and organizations, but I've never really stopped programming. So I've done a lot of hands-on pair programming, for example, and so forth.
So you're still spending most of your time programming?
Yes, actually, in the beginning of the year, I made a decision to join a team for a longer duration. So that's something I've been talking about for God knows how long, and now I decided to do it. Actually, so I've been a project team member for 7 months now.
Okay, and that feels good. Better than being just a coach.
Yes, I think it was about time. So for the past 5 years before this engagement, I'd been working on the same code base continuously for a maximum of 2 weeks. And then I'd go somewhere else. I maybe come back, but still it's not the same thing. So I was starting to miss the frequent small wins and going live and getting a defect from production and so forth.
And it feels good getting defects from production?
Not that good, but...
Well, let's get to that later. The reason I invited you is that you published a book. I guess it was in 2008 or late.
It was actually 2007.
2007, yeah. And it's a book about test-driven development. The title of which is
Test-driven.
Test-driven. Being driven by something comes with a slight connotation of being addicted. So do you consider yourself being a kind of test junkie?
To some degree, yes. So it definitely feels awkward to work without tests. So in that sense, yeah, I guess you could call me a test junkie.
So do you do that from time to time, working without tests?
I'm afraid I find myself in that situation every now and then. So, for example, there's a legacy code base at work where I'm working right now, and there's a lot of places that don't have a sufficient coverage with tests.
Mm-hmm.
Also, there's some technologies involved that make it really hard to write tests.
Mm-hmm.
But and it feels weird. So definitely much better, a much more enjoyable and confident feeling when you develop with tests.
TDD has been around for a while, and still different people mean different things when they use the term. How would you define test-driven development?
I've had some discussions with Jim Coplin about this. So technically, I believe the first time test-driven development was defined in published writing, it did refer to mostly test-first programming combined with the idea of the tests and the simplest thing that could possibly work, kind of implementation, and the next test, the implementation test, that kind of back and forth driving the design. So
you're talking about the test-driven development cycle there?
Yes. Well, so the I believe the original definition was, I can't remember where it was, but the first descriptions of TDD were a combination of you first write the test and then the implementation, and an emphasis on emergent design, so that your design evolves strongly influenced by the tests that you write. And I think personally, I have a less strict definition for TDD in my mind. So I'm mostly, when I say TDD, what I'm really thinking of is kind of a lightweight version of that. So test first, definitely, but you do think about the design before you start, and you do have an idea of where you want to drive your code base, but you still let the code tell you that this doesn't feel right. Maybe we should go into a different direction. So there are definitely different definitions, and that's more or less mine.
So what are the components of test-driven development? You already mentioned writing the test first and letting the code tell you where to go afterwards. So I imagine something like doing refactoring after the test or during the test?
Yes. So basically the TDD cycle being test, code, refactor, those could definitely be components. So that's something you do all the time when you do test-driven development.
Is there more to test-driven development yet that you think is absolutely necessary?
I think there is, yes. So, for example, if you look into the various studies, there's numerous studies, research papers about the effectiveness of TDD, the influences on quality, code quality, and so forth. And when you look at the studies that suggest that there might actually be a negative impact on quality when you use TDD, when you look into the actual results, what they find is that certain object-oriented metrics, they get a lower score on those. Mm-hmm. But it's not actually due to test-driven development as a method. it's due to a lack of object-oriented design skills. So basically, TDD is a vehicle that gives you a very natural rhythm to do good object design. The problem is that it doesn't magically give you the sense of what is good object-oriented design. So I think that is a kind of a missing or the unmentioned component of TDD.
So you don't think that TDD makes a good programmer out of a bad one, but does it work the other way around? So that I have heard people say that doing TDD would distract developers from really looking at the design and so being sloppy about it.
Yeah, I've heard similar remarks every now and then. I don't see it that way, though. I kind of get the idea of a new workflow sort of causing a disruption in your current way of working, and there's definitely a learning curve when you start doing something as drastically different as you've done before. But I do think that it actually helps you improve. It's just a different perspective, a different point of view into looking at what you're doing and looking at your design. You're basically using your tests as a design tool.
Well, we'll later get back to that, how tests can improve design. I first go to one of these basic things. You said that the first step in the TDD cycle is writing a test. So it's obviously it will be a test about something that doesn't work yet. How can you, right?
Right, yeah.
How can you test something that doesn't work or even exist yet?
Oh, well, that's because we're in TDD, we're using the word test, we're kind of overloading the meaning of it. So when we write a test as part of the TDD cycle of test code refactor, we're not actually verifying anything. We're expressing a desire. We're expressing something that's missing. We're talking more in the domain of specification rather than verification, right? So we're simply pointing out something that's wrong or missing from the current implementation.
Missing in terms of the user requirements?
Depending a bit on your code base, of course. Sometimes it might be something fairly low level and technical. After all, we are working with objects, pieces of code, and every now and then the piece of code that you're working on might actually be very close to the user's domain. So it depends.
So would you say that most of the time the test I write could be translated to a user requirement? Or the other way around, a user requirement could be translated into such a test? Or is it the rare occasion that I'm working on the outside of my system?
Well, your mileage may vary, but personally I tend to be working below the user requirement level. And to some degree, it is due to the kind of systems that I work on and the kind of code base that I inherit from someone else. But that's what I tend to see around. I also I know of several people who mostly work on higher level tests, and they basically work outside in all the time, or at least most of the time. And for me, it's kind of the opposite. So most of the time I work inside and try to grow things towards something that's big enough to actually mean something to the end users. And then every now and then I have the luxury of working on something outside in, specifying things from the system perspective.
When you say luxury, is that the better way?
For me it is, at least, simply because for me it's so rare. But it's hard to say if I do it all the time, I'd probably be doing it maybe a bit too much every now and then. So basically, I believe that there's somewhere in the middle. There's the theoretical optimum, and it's not actually that important where it is and what it is. It's good enough that we sort of find our way towards that optimum wherever it is, rather than diverge from it.
Mm-hmm. You mentioned the learning curve, so obviously you were a beginner once, and there must have been a time when you got hooked into TDD and said, "Oh yes, now I feel or I can see that it gives me value." Do you still remember that time?
I have vague memories from that time. I do remember this fuzzy era of my career when over time I went from basically breaking the system and hacking it until it works again, and then breaking it again and making another step, hoping that I actually get to fix it rather than revert my changes. And going from that into much more steps where I actually don't break the system for a long time and completely shattered, but rather point out what's missing with tests covering my back and then implementing that, making sure that all tests pass again. Somewhere in that transformation, I got hooked. And basically, nowadays it feels weird if I don't have the test covering my back.
So has your work experience changed fundamentally since this point in time when you got hooked?
It has definitely. I've stopped stressing that much. So basically, for example, when we go live, the project I'm working on right now, we deploy every 2 weeks. I don't really have any stress about. Oh, I hope there's no defects and so forth. It's the defects that we get. They're so rare and they're so non-critical that it's actually a lot less stress these days compared to, say, 8 years ago.
When you say you have so few defects, can you tell us something about the numbers?
I wouldn't know. So the system I'm working on, it's existed for years. I've only been there for 7 months, and they have all kinds of systems full of different kinds of tickets, and most of them are really irrelevant and so forth. I have no idea how many there are. But basically, basically when we start a new 2-week development iteration, we don't have a massive amount of defects and a couple of new features. We basically have mostly new features and maybe 1 or 2 bugs to fix. So.
I guess I didn't catch you using the word unit test. You said test, you said specification, but very often people use the word unit testing and test-driven development as a sort of synonym. What do you think? Is it the same, or is just doing unit tests something completely different than doing TDD?
Well, I don't like the term unit test that much. I do use it every now and then, but it has this problem that when you go to an organization, the word unit test has or may have a completely different meaning there compared to yours or another company's. So first of all, unit. Well, what's a unit? Well, our technology is this, and we don't have objects, so we don't have classes. What's our unit? Well, it's a source code, a source file, for example. And they have this completely different taxonomy, and unit test means something. And then in a different company, their unit tests are obviously very micro level, very small. They deal with one or two objects at a time, and so forth. So first of all, there's this problem with terminology. Second, I don't think that. I think it's somewhat arbitrary to say that you should test drive with certain types of tests. So even though most of the tests that I write when I do TDD are such that you could call them unit tests,
meaning they on a very fine granularity, just testing
yes.
a single method or object.
Yes. So most of the time, the test that I write, it involves a couple of objects. No side effects. If there are side effects, I make sure that I clean that up so that for the next test, it's a clean plate again. But most of the time, it's a couple of objects doing something very very small, specific, very isolated. But every now and then, I do write other kinds of tests. For example, I might set up a small cluster of graphical components. Basically, create a tiny application where these couple of GUI components they both exist there and they interact. And that's no longer a unit test according to the stricter definitions. But I think it still makes sense to test drive that particular thing. And in that situation, that approach might be the best.
So you would really go to the graphical user interface and test that? That's
well, preferably not the whole interface, but small portions of it. So you might have a button and a text field, and they have some kind of interaction that you want them to have. So you might just pop up a small tiny window that has just one button and just one text field, nothing else. But basically, you're already bringing in plumbing in the form of the graphical user interface framework, Swing or something else. So that's already a bit too much infrastructure to be called unit test. Maybe. But it depends on your definition.
But doing some tests on that level, I guess you'd require other tools than just a plain JUnit, NUnit, or whatever to be able to to click buttons, stuff like that.
Yeah. If you do that a lot, then I think you should at least consider using some kind of frameworks, or pay very, very close attention that you're not creating a maintenance nightmare for yourself. Basically, refactoring your test code, extracting the different similar things, and basically starting to build up your own test harness for that kind of code.
Mm-hmm. But you don't need special tools like capture replay technology, or I've heard.
Yeah, the capture and replay. That's it's a nice idea. The problem is that you don't have something to record. So if you're missing a button somewhere, how do you record that when you click a button, something happens? You don't have the button.
That's a fair point, yeah. I hear people talk about using TDD in all kinds of areas like Java, .NET, Python, Ruby, you name it. Have you hit upon technologies that do not lend themselves well to test-driven development, or where you can't do it at all?
Well, certainly some technologies make it a lot more difficult to write tests. for example, last year I was in Bangalore, India, and I was there for visiting a Java team. But right in the next room there was this group of people working on C code, and we kind of agreed that I go and see if I could help them, and it was interesting. I'm not a C programmer by any means. I don't have the in the know about all kinds of things that you can do and so forth. But we did look at it and made some progress. The thing is that the language makes you really work hard for getting those tests written. You can do it definitely, but it's a lot more verbose, and say the APIs available, the testing frameworks, they're much lower level than your regular JUnit or NUnit and so forth. So that's one side of it. But there's also the other side which is actually very interesting. When you work with languages that need compilation, like with the C guys, well, when I work on Java in a modern IDE such as Eclipse, I basically just I type, and then I run tests. I don't compile because the IDE does that continuously. So it's so instantaneous that you don't have to think about it. But when you work with C, for example, compilation is actually a big thing. So when you want to run the tests, you have to stop. You have to compile, and it takes a while. It might take a couple of seconds, but it might take 10 seconds. And then you run the tests. So the feedback cycle becomes, it's no longer 1 second, it might be 10 seconds. And that actually fundamentally changes the way you run through your TDD cycle. My friend Bas Vodje calls this, I can't remember the exact term, but basically he's talking about this optimistic locking type of TDD, where when you stop to think about something, you basically you save and you start compiling and running the tests, and then you continue typing again immediately. So basically in the background the compiler is compiling, and when the compiler is done, you run the tests, but you're already moved on. So you're already continuing with the expectation that the test will fail or will pass in a certain way. So you assume that your assumptions and understanding of the code is correct. And most of the time this might work, but every now and then it turns out that, oh, the test didn't fail. It was supposed to fail. Or, hey, the test didn't pass. It was supposed to pass. So you made a false assumption somewhere, and you have to basically rewind your mind and whatever code you've already written after the last test, basically. So you have to go back and stop again, think about what's going on here. So it's a bit. You can do it, but it looks different. It feels different.
So do you think TDD in those environments is still worth it? Where's the border? How long can the feedback cycle take that it's still worth doing TDD?
42. I
42.
have no idea.
Ah, okay.
Yeah. I'd say that I haven't seen an environment where I wouldn't consider TDD being beneficial, or at least potentially beneficial, because after all, it's up to the individual. Yeah, personally, I haven't seen an environment where I wouldn't do TDD.
Have you ever worked in a C++ environment with big systems that take like maybe 15 minutes to build, or even longer?
Personally, no. I've talked with some people. For example, this very interesting situation where a London bank. They're working on C++, and basically their tool set is something like VI or Emacs. They don't have built-in refactorings in their fancy IDEs. There are no IDEs. Well, there's Visual Studio, but anyway. So they still did TDD, and for example, refactoring they did by writing shell scripts that mangle your source code, your source files with regular expressions, tools like sed and awk. And that sounded very, very laborious. But they decided to do it. So obviously they continued doing it. So obviously they saw the value. Even though they were working on a big system with difficult technology and C++, it's not the friendliest, the programmer friendliest language. And well, personally, I haven't seen that, but I've heard a lot of people say that it can be done, even though it sounds awful. We actually do it, and we're happy with it.
What I see are two sides. The one side is it worth doing that from objective view? Like if you count the number of defects and the time you save not working on those defects because they didn't get into the production system in the first place. And the other side, how does it feel to people? So what length of feedback cycle do normal developers get up with so that they still bear this heavy load of going through this cycle?
Well, it's very hard to say.
Yeah. Now let's get back to some of the more technical things. Like you mentioned that you sometimes go away from the strict unit testing and testing in isolation thing. But when you want to do that, and you have things like file systems, databases, and stuff like that, you probably have to decouple the object you want to test or the unit you want to test from other things, from infrastructure, from databases, and stuff like that. How do you go about that?
Well, one of the core techniques there is basically dependency injection. So you basically avoid using the word new if you're working in Java. So you don't you want to decouple the code under test, or the code that you want to test. You want to decouple that from the implementation of its collaborators. So, for example, rather than in your constructor saying this.foo equals new widget, you basically pass that widget that you need, the dependency from into your constructor, that kind of thing. So basically, in your test, you can then compose objects with some of their dependencies faked out, or using mock objects or something like this. I think that's the most essential technique there.
Is it a difficult technique? I have heard use the word mock objects in so many different ways that it sometimes confuses me.
Well, I don't find it that difficult, but I'm curious about the confusion about mock objects.
Yeah, sometimes people talk about mock objects and just means an object implementing an interface that just returns a predefined value.
Right. Yeah.
Sometimes they're using something like EasyMock to have a seemingly complicated way to define the behavior of this mock object during the test time. So there are obviously some different kinds of mock objects.
Right. There's a couple of taxonomies in play here, I think. One of them is basically written by Martin Fowler. So he some years ago he wrote this article called mocks aren't stubs, I think. You might want to check the title, but
yeah, I will
anyway,
put it in the show notes.
Right. So he provides this classification, which I think is fairly global. That there are stubs, fakes, and mocks, where stubs would be the most simple implementation of an interface you can think of, where the methods basically they either do nothing or they return a fixed value, a null or a 0 or 15, something. You basically hard code everything. Then there are fakes, which are more like a lightweight alternative implementation for the real thing. So basically, when you take a fake object and you poke it, it acts like the real thing, but it's not the real thing.
So as an example, if I have a fake database, then it would really store values, store columns, stuff like that?
Basically, a fake database could be a hash map.
Oh, I see.
Or something implemented on top of a hash map. So you don't actually persist anything as such to a disk, but you rather keep all of those objects in memory. And when you do a lookup, you might iterate through all of the objects until you find the one that you're looking for, and so forth.
So in a way, it's simulating the real object.
Yes, you could say that. Yeah. Mm-hmm. And then there's the third category, the mock objects, which would be more like configurable spies that you can take a mock object for a given interface, and then you can tell to behave like this when this happens. And for example, you can tell them to fail your test if this happens. That kind of things. So I think that's a fairly global, universally accepted classification or taxonomy of different kind of test doubles, if you will.
Does the testing framework of your choice give you the capability to have those kinds of mock objects, or do I need other tools for doing that?
Well, depending on your technology, of course. Personally, I mostly work with Java, and for the past couple of years, I've increasingly been using this tool called JDave. So JDave is a testing framework of one kind, and it integrates JMock. So it gives you a built-in facility for creating mock objects, and it happens to use JMock underneath. But there's a host of other equally good frameworks for doing that.
So usually I need another framework for doing that.
Basically, yes. You can write mock objects by hand, for example, but it does get tedious. So yes, you do want to use a framework or a library.
Yeah. So I understand that I can mock out or fake out objects, dependencies, when I do not want to test those. But at one time or another, I will have to need to use a real database or the real file system or calling the web service. How can I test drive those?
Well, one example of a situation where you do that would be, for example, a data access object. So let's say you're working on an application that's sitting on top of a relational database. And you have these data access objects that are responsible for moving data from the database and turning them into objects that you can manipulate and work with. Or they might take in a domain object and make sure that it gets persisted into the database. So how do you test drive those? Well, you there's a couple of ways. For example, in Java, you could mock or fake the JDBC interfaces if you happen to use that API, or you could actually launch an actual relational database and run your test against that database. And there, I think that's an example where I by default maybe go with the database.
But you're not thinking about starting Oracle, which takes half a minute, and then opening a couple of sessions, which takes another 10 seconds for every session?
Yeah, so that's where I'd actually go for the lightweight implementation. It's like H2 or HSQL. So there are a bunch of in-memory databases that are really lightweight, and they take a fraction of a second to launch.
Okay.
So basically, using a lightweight database, you might call it a fake, but it is a proper database. It's just not Oracle or MySQL. So when I work with, for example, if you work with Hibernate, I'm not sure if you're familiar with it, but it has its own query language, and I'm definitely not a Hibernate guru or anything. I have trouble remembering how to do this and how to do left outer joins with Hibernate's query language. So if I fake everything, I can write a test. I can write a test that says when I do this to you, Mr. Data Object or Data Access Object, then you should make this kind of an API call to this Hibernate interface that I mocked. But I have no idea whether that API call, the syntax of the query statement, whether that's correct or not. So I'd rather work against the real database so that I can actually write meaningful tests that tell me something.
So what I take from that is that whenever you're using mock objects to step out stuff, you really have to know this stuff quite well, at least the API and how it's going to be used. Otherwise, you can't write the correct mock object for it.
Exactly. Another example of a sort of technology domain where I find myself doing kind of a similar compromise, if you will. Basically, not using extremely isolated kind of pure micro tests.
So what about the costs of doing test-driven development? Is it more expensive to develop in a test-first style than to program without automated tests? I guess most people would argue that it is, at least in the beginning.
Well, there's definitely a cost of the learning curve. So you do have the initial dip in productivity. And then there's a bunch of studies and research that attempts to prove or measure some kind of a difference between test last and test first, or test first and test never. And the problem there is that it's never really a solid proof, because you'd really have to take the same persons or the same people and let them work on something with one technique for a while, and then basically brainwash them and make them forget everything they learned and found out during that time, and then have them redo it, the same thing with a different technique, to get a meaningful comparison. So there's a bunch of research that suggests this or suggests the other, but basically I find that it's down to our subjective opinion, really, whether it is more costly or less costly, and so forth. And personally, I have no doubt that it is more productive for me to do test first than test last.
What about the teams you've seen? Is your impression that they are getting faster with time, faster than they were before you started introducing test-driven development?
I'd say that they tend to get faster. Again, the problem there is that TDD is not the only force in play. So also over time, you grow your code base. You might grow your team size. Suddenly you started with one team of 5 people. Now you have 2 teams of 5 people. Or you might have 10 teams. So over time, all kinds of other variables change. So it's really hard to say whether they've actually gotten faster or not, because the overall output doesn't directly relate to the productivity of an individual. But there's a lot of variables in play. But again, subjectively, in my opinion, the teams that adopt TDD, they do get faster compared to what I imagine that they would be if they hadn't adopted TDD. A lot of it is due to having tests. So I think that the biggest difference comes from simply having enough unit tests to give you this comfortable safety net. And on top of that, there are some benefits from improved code quality, improved design, and of course other things like people learn.
Yeah. So some argue that having too many tests will slow you down because you not only have to change the code, the production code, but also the test code.
Right. Yeah, I've heard that a lot. I think that's perhaps a second major sort of unmentioned core of TDD. So it's not enough to just go through the cycle of test code refactor. You also have to have some kind of a vision, some kind of a sense for object design. And you have to refactor your test code as well. It's not just refactor production code, but you have to be as merciless towards your test code.
Do you think the same design guidelines principles hold for test code as for production code?
I believe they do. But again, principles are principles, not rules. So, for example, you might have different principles suggest opposite directions, and basically you have to make a subjective decision that, okay, so this here there's a bit of duplication here, but having this bit of duplication it gives me a slightly better understandable test, for example. So you might decide to leave that bit of duplication there, even though certain principles suggest that you should get rid of it.
And you wouldn't find those situations in production code?
You might, but it's a slightly different world. So in production code, you tend to have less of this like data-driven type of blocks of code, whereas in test code, when you're basically describing scenarios, not the domain as such. So you're describing scenarios which are inherently a bit different nature than the problem domain that you're trying to model with your production code. So I think there is a difference. It might be subtle, but I think there is a slight difference.
Let's go to something not completely different, but different. in your book, you differentiate between test-driven development and acceptance test-driven development. And you told me that you're also doing a bit of behavior-driven development. What's the difference between those three, or is one just the evolution of the other, or how could we pick those three things apart?
Right. So I'll pick on the behavior-driven development first. The origins of BDD, or behavior-driven development, are very close to TDD. The term BDD was coined by Dan North, and according to Dan, he adopted this new vocabulary where you don't talk about tests but specifications and behaviors in order to better teach test-driven development. So I mentioned earlier that we've sort of overloaded the meaning of the word test. So a lot of people have this built-in idea of testing meaning verification after the fact. And in TDD, we're talking about this upfront specification of what doesn't exist yet. So there is a mismatch. And what Dan wanted to accomplish originally with what he then called BDD was a different vocabulary that better suits the mindset of test-driven development. So that's where BDD started. But it has evolved to kind of two directions. One is TDD evolution into basically developer tests, very micro level, but expressed with a slightly different vocabulary. So where you want to express your tests not as tests, but specifications.
So TDD done right.
Basically, TDD done right. And the other direction is then actually a step towards acceptance test-driven development. So going away from the low-level like unit test type of tests or even specifications, and trying to go outside in, so that you express things from the user's perspective, and you start getting more into the domain of the end user, the user interface, the ubiquitous language of the users, not the programmers. So then naturally there's a link towards story testing or acceptance testing. And then that's, I think, the two major directions that BDD has evolved to.
So would you think that BDD makes TDD and acceptance TDD redundant?
That doesn't sound right. I wouldn't say that. I'd say that BDD in these two different forms, they're just variations of TDD or acceptance test-driven development.
But as I understand you, BDD can cover both camps.
Yes. So the term again, it's a bit overloaded. So that you have different kinds of BDD. You have the code-oriented behavior-driven development, and you have the feature or functionality oriented BDD. Now, probably you're using different tools for these different ends of BDD, the BDD spectrum. So in practice, you are actually doing two different things, even though both of them might be called BDD, depending on who you talk to.
Mm-hmm. Do you have any preference in tools for BDD?
Well, I mentioned JDave earlier. and I call it a testing framework. It's actually a behavior-driven development framework. So it embeds these concepts of behavior-driven development and its vocabulary. It's basically its inspiration has been RSpec, which is a Ruby-based tool. And actually, RSpec or nowadays Cucumber, which is kind of an offspring from the RSpec project. Cucumber would be it's kind of my favorite tool for the acceptance type of BDD.
So when you're in projects, do you still consider to use, what's them called, legacy acceptance testing tools like Fitness?
Well, I haven't worked with Fitness for extended periods of time, so I bumped into it several times, written some fixtures and so forth, and I found it to be a reasonably good tool. But I think there's a big enough difference with the kind of tabular table-based, or even the narrative, more narrative variations of fitness fixtures, for example, and with the kind of test ID or scenarios that you can describe with tools like Cucumber. So the difference is not huge, but it's big enough that I don't really consider tools like Fitness anymore. Of course, if there is a legacy, there's an existing base of fitness tests, then I'd probably end up continuing on that path, at least to start with. But given a clean plate, I'd probably go for Cucumber or something like that.
You told me that you are about to write another book. What's it saying?
Yeah. Well, it's actually it's about unit testing. So my publisher, Manning Publications, they asked me if I'd like to work with Roy Osherov. Roy wrote a book called The Art of Unit Testing, and it's a .NET book. So Roy's a .NET guy, and I'm a Java guy. So this collaboration is going to become some kind of a translation, if you will, of Roy's book into the Java world. So obviously some of the concepts are different and do not apply. So there'll be it won't be a direct translation, of course, but something like that.
So, but it's going beyond the plain test-driven stuff.
Yeah, well, we will mention TDD and give a short introduction, but basically the focus there is on the art of writing tests or specifications if you use the BDD vocabulary.
So on the really geek level, word for word.
Yes, it's going to be a geek book. A lot of code, 100 or so code listings and so forth. So it won't be something your grandmother reads.
When it's going to be out?
It's hard to say. We haven't really started yet, but it's not this year. That I can say for sure. But we'll see. A year from now, I hope to have it in my hands.
Okay, that's pretty ambitious. Before we wrap up, is there anything else you would like to add?
Well, that's a tough one.
Yeah.
Oh, you caught me by surprise there. Nothing comes to mind.
Nothing comes to mind. So I actually have a question on my mind. Last time I met you, that was at Agile 2008 in Toronto. And you were one of the stars in Programming with the Stars, which is basically a competition of pairs doing test-driven development in public.
Right, that was a lot of fun.
Yeah, and you won the competition, actually. How did you do that?
We pried Joshua, the one of the judges, Aside from that, I have no clue. I guess we picked technologies that were kind of interesting to the audience, and I guess we entertain people enough.
Okay.
It's really hard to say.
Okay. Thank you, Lasse, for taking the time to answer my questions at length and in great detail. It's been a great pleasure to have you here.
Likewise. I'm no longer that nervous either. So
no am I. Yeah. Hope to see you soon, and bye-bye.
Bye.
Thanks for listening to Software Engineering Radio. Software Engineering Radio is an educational program brought to you by Hillside Europe. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example, by clicking on the Dig Reddit Delicious links and the /dot button. To contact the team, please send email to team@se-radio.net, or if it is specific to an episode, please use the comments facility on the website so other people can react to your comments. This episode of SE Radio, as well as all other episodes, are licensed under the Creative Commons 2.5 license. Please see the website for details. Thanks to Charlie Crow and the Podsafe Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.